1 minute in, so that's okay. And nearly sits on 60% for a while. There we go. Now we're at 100%. Okay, so this is CET498, the first 3 detailed design presentations. Just to remind everybody, including me, where we are. In fact, we are at the end of the red box, right? We're doing the detailed design review. So we're about halfway through-ish. The next piece is to get the prototype going and finalize the design and then report out what happened. And I thought I changed the colors of the previous ones, but that's the red one in the middle there is what we're doing tonight. Okay, so I think the aim is, the order of presentation is lit, motion powered light and Laundralarm. And so what I think we should do is get Mini-Me off the screen. There we go. And I will take that away and I will stop sharing, and whoever is going to be the sharer on the lit team should share. Okay, so I'll stop streaming. Actually, maybe I should keep streaming. Yeah, why don't I keep streaming? That way I think we should be okay. So who on lit is going to present?
I am. I'm about to share my screen.
Okay.
Just let me know that you guys can see it.
Let me, yeah, looks like I can. I'm just going to pull that over here so I can...
All right. So this is lit in our detailed design presentation. I'm Nikki. My other teammates are Sydney and Jordan.
Yeah.
So our project overview, it basically stayed the same from the beginning. It's, we're still making our LCD screen to display messages via Bluetooth, and our goal is to help small business increase their sales and foot traffic. So this should be a new way of marketing. Our success overview so far, COVID has delayed a lot. We've recently got our supplies and everything for our project, so we're probably like a week in actually doing stuff. Also with this time, it's been a code refresher, so we just, trying to make everything work. And with, COVID and finances changing and everything, we decided to downsize our project because we did take the advice from Professor. We were going to try to make a bigger board, but especially with funds being a problem now, we just decided to just stick to what we were doing. We kind of switched it up a little bit, but we stuck to what we were doing with the smaller board to see how it could go. So, interface update.
So for the interface, we're using, we're basically using the Arduino, and that is gonna be, it's gonna be talked to via Bluetooth, and it's gonna come from a Samsung tablet, but it can come from any Android device. Should be able to talk to our Bluetooth, run it through the Arduino, and display it on the LCD screen. The system behavior, kind of what I just went over. So we have our Arduino, our Android device. It's going to be paired via Bluetooth. We have an app on our Android device, which is a Bluetooth terminal. We write text on the app. it sends it to the Bluetooth, which goes through the Arduino, displays on the LCD screen, and then as for right now, it has to be manually reset in order to send new text, but we're working on that.
We have started a new design update. We changed since we got the new Arduino. We changed the whole schematic and everything. Well, it's slightly similar. We just added one more piece to it, and it slightly looks the same. With our updated parts list, since we got the Arduino Uno from Professor and the Samsung tablet, that's something that we didn't have to purchase. We purchased the starter kit, the Bluetooth module, and a soldering iron because we're going to make a casing for our LCD screen. So our new schedule, since we received our parts in late September, we worked on receiving our parts in September and starting on finalizing the code. In October, we're going to try to test both the hardware and software components, make sure everything is working, troubleshooting the code, make sure, if there's any problems, we could fix it and figure it out during this time. And also begin to configure the casing that we're going to build for around the Arduino. And then in November, just finalize up the project so that we could make sure that it's working well and that we could actually get this project done. Like, we're very projecting to get this project done. Jordan.
So lessons learned. What did we learn? We learned to expect the unexpected. This basically has to do with the COVID pandemic, or parts not working, or just the code that we made not actually doing what we wanted to do. With that being said, we learned that we should have backup plans to everything, which is why we downgraded the size of the LCD screen to a smaller one. And also working together, yet separately. I don't know if that makes so much sense in words, but in my head it did. Basically, we when we first came up with this idea, this project, we thought we were going to be able to meet up, do it hands-on, everybody kind of get to help build it, test it out and stuff. But with COVID being a thing, I have all the actual hardware parts here, and no one's actually been able to see it physically other than me.
Yep. So in conclusion, our goal is to create a new signage that will help businesses. Due to COVID, there was, a bit of delay with receiving materials, a delay with receiving funding to finalize our project. Also, with this change, we decided to, create a new schedule and have a simpler design so that we can get this done and get this done efficiently. And even within a new way, we can get this accomplished. So that is all for Lit.
Okay, thank you. Does Yay! Does anybody have any questions for the Lit team? So I have some questions, funnily enough. I was hoping to actually see some pictures of the hardware that you've got.
I literally was like, oh my gosh, I forgot to put the pictures in the slides. 1 second.
So if you would be able to share them, that would be interesting.
Yeah, I could share.
Because it's great that you got the components, and it doesn't have to be together. I just like to see the bits and pieces.
1 second. I think it's still. Is it still showing my screen?
No, I think you stopped the
Okay.
the sharing.
Let me just put them in there, and then I can show you real quick. Discord. What just happened? Screens. Yeah, just share the entire screen. So here we are. This is what we received. So we did try to start doing something with the code, and it shows that those blocks at the bottom when we were trying to send a message, and I guess it truly wasn't going through. But this is what we have so far with what we received. So like with this one.
Basically, these pictures are showing that there was a step-by-step of kind of putting everything together.
Yeah.
I got everything powered on, and I got there wasn't showing those text blocks on the LCD until I added in a 10K potentiometer, which is in the bottom left. It's that
This right here.
The trim pot there. Yeah. Okay.
yeah, and so that was I took a picture of that because it was progress. We got something on the screen. Now we're just working on getting the code to actually move onto the LCD screen, and then unfortunately it has to be hard reset by pressing the reset button on the Arduino in order to clear the
Okay.
text. I haven't found out how to just write new text in there to overlap it.
Okay. What's the I don't know, white or translucent box on
This
the?
right here, that's the Bluetooth module.
That is the Bluetooth module. Okay. Okay. And that's
Yeah, I got a fancy little case around it, so I didn't.
fair enough. Okay. Cool. That all sounds pretty good. Any other questions from the audience? No? Well, give them a round of applause. Thank you. Okay. Next up is motion powered light, I think. So would somebody from that team share their screen, and I'll there we go.
Can you guys see the screen?
Just about. There we go. Yeah, I can see motion powered light detailed design presentation.
Matt, can 1 second. Just want to make sure that both the teammates here.
I'm here.
Okay.
Yeah, I can see Ari and Matt in the classroom. So.
Alright, so I'll start off with our presentation. So our project is the motion power light, and we're trying to generate a product that can create electricity to power up a flashlight. So I'm going to go over the overview of our presentation. We're going to explain what our project purpose is, the design of it, the setup, and then the budget and schedule. So the reason that we decided to do this project is because based on one of our teammate mentioned that 1 billion people over the world are without electricity, and getting electricity, it's not as simple as just going out there and buy some batteries or plug it into the wall. So we're trying to make something as simple as possible, so that people can get access to something as simple as a flashlight or So the way that we're trying to do this is to have like what's it called? a user-friendly device that where we can generate electricity and use that electricity to power up a flashlight. So as shown in this case diagram, the user who's moving is gonna generate electricity through a magnet pole that we're trying to design, and from that magnet pole, it's gonna generate electricity and it's gonna be charged up into a battery, where that battery can be used to charge up a LED light bulb. You guys can still see the screen, right?
Yeah, I can see it fine.
Oh, okay, yeah, I'm not sure why my other screen is showing something else. Okay, sorry. So the system overview, the motion power light should perform 3 tasks. And so one is to generate electricity for the user in motion, store the electricity, and apply that electricity to a LED light so that people can use it.
Hi everyone. So like Wei said, our project is to create a device that somebody can use and generate electricity and use that electricity later. But we want it to be something that the person who wants to use that energy generated later will sit down and concentrate his time to generate electricity. So that's why we thought about that solenoid with the magnet that we're gonna be flying into it, so that with the magnet flying through the solenoid, it can generate electricity. Next slide, please. So we want to know how much electricity we want to generate so that we can use that electricity later to power our LED and have the lights. That's why we have the voltage formula over there and then the inductance formula too. With those two, we can calculate the amount of energy that we can generate and use that later. Next. So one problem is to generate the electricity, and the other one is to store it and use it later. So we have in mind using a battery or a supercapacitor. And with those two devices, they both are great devices, but one of them is better than the other one. And we think the battery is better because once we generate the electricity and store it in there, we can use it for a long period of time. But a supercapacitor can get charged really quick, but it won't hold the charge for a long time for whatever we want to do. Next slide. So after we generate the electricity and store it, we want to be able to use it for a long period of time. That's why we want to add this third party component, which is a booster. So the way the booster works is when you put like 1 voltage in the, it will transform that voltage, make it higher, up to 5 volts, so that the LED that we chose can be able to use it and be bright enough so that the user can have enough light to see and do his things around. Next. And then you can see the picture of the LED that we chose. It can support up to 5 volts, so it's good for our project, and it's bright enough. We have it, we tested it, we see how bright it is, and we do like it. Next.
So this is the schematic for our. To the left, the inductor symbol is actually our copper coil that'll be wound up around our plastic case. The coil will have magnets back and forth through it that creates an AC signal. The AC signal will then go through the bridge rectifier, D1, and this will change the AC signal to this new DC signal is then stored in our 3.6 volt rechargeable battery and also sent through a boost converter. The boost converter helps to step up the given voltage to a higher level. Finally, this voltage powers our LED if the switch is on. Next slide. From last semester, our schedule has changed a lot. We first met this semester on August 31st, and since then we meet up every Monday in person. Currently, we have a prototype made and are finding to make creating and storing voltage more efficient. After this, we will only need to design a comfortable case, possibly using a 3D printer that'll fit our components. Next slide. Here's our budget. We have bought more components than we've shown for testing purposes, but we believe this is what a final run us. Next slide. In conclusion, too many people around the world access to electricity and light. This project should cost about $30.34. This cheap development costs will enable many who need it to be able to purchase one. Not having access to school facilities and their devices due to coronavirus actually haven't made things much more difficult for us, and we believe we will finish our project on time. It's just some references and any questions.
Cool. Thank you very much. Do there any questions from the audience? Well, I have a few. So, what do we got? What's the stream I'm watching? Here we go, questions. So, could you just go back to the circuit diagram? Yeah, that one. So, I'm a little concerned that charging that battery needs a little bit more happening to it. So I'm just not. I don't know the details of charging a lithium-ion battery, so I can't speak authoritatively, but I believe for certain types of batteries that you need to do some limits, like you need to limit the voltage, you need to limit the current appropriately for the battery to charge well. Can you comment? Have you actually managed to get the battery to charge like that?
Right now we try with 1.2 volt battery, and we were able to charge it, but we just don't know if it's because 1.2 volt that is not charging above that limit. And plus, when we use it, the light just come on and then go off right away.
Right, and yes, so that's okay. So you might need to put a switch in there. Just see if you can find. I might see if I can dig about charging lithium-ion batteries. It might make the circuit more complicated, but it might make the charging more efficient. Is my main concern.
Okay.
That's one thing. You came up with a total cost for what you have at the moment. That's good. Do you have any idea about what the cost might go down to if you decided to build 1,000 of these or 10,000 of these? Do you have any idea what about the how the unit costs change if you go to a manufacturer and say, hey, I need 10,000 of these or 1,000 of these?
I mean, component wise, the more you get, the cheaper they'll be.
per component. That's right. So that's what I'm asking. Do you have any idea what the just say, and it doesn't matter for now, but for the final presentation, it'd be nice to know, this is what we paid, $30.34. But if we did it, if we scaled up with manufacturing and we decided to make 1,000 of these, then it'd cost, I don't know what it cost. It might be $25 or it might be $10.
Yeah, I won't be surprised if it goes as low as $20.
Yeah. No, I think it could very well get quite cheap. Some of those components there, I think, can be had more cheaply if you're getting them in bulk, right? If you're getting lots of them. Okay.
We also have a video if you guys want to see what we have for now.
Oh yeah, that'd be cool.
So this is the first prototype, and we're trying to measure the voltage as we're trying to generate them. I'm not sure if you guys can see it.
So that's the voltage being measured there, is it?
Yep.
Yes.
Yeah, cool. Very cool. Oh, and that's the plastic tube with the copper coil around it and the magnet inside. What sort of magnet? What sort of magnet did you use? I didn't check the list. Is it one of the high power ones?
Say that again. I didn't get a question.
What sort of magnet are you using? Is it one of the I've forgotten the name of the neobidium, or is a particular sort of magnet that is
No,
really...
they are like coin cell magnets.
Okay. So,
and we stuck like 10 of them together.
Okay.
In there. Yeah.
Yeah. Okay. Okay. Does anybody else have any questions? Thank you very much for the presentation. If there's no other questions, let's give them a clap. Thank you. And we'll go on to Laundralarm. So Laundralarm, I think you have a video, and then we'll question you afterwards. Where are we? Watch stream.
This is the Laundralarm team, and this is our detailed design presentation. Our group members are
Daniel,
me, Adonica,
and Nasmeen. In our daily lives, we're always busy and we are driven by increased workloads in modern technology. People tend to forget certain things throughout their days, such as forgetting their laundry. And I'm sure we've all experienced a situation like this. Our solution to this problem is Laundralarm, a laundry reminder system that will notify the end user when their washer and dryer cycle.
I guess the audio isn't working on the video.
oh, it's not. Oh, okay.
Oh, I could hear it. Huh.
Yeah, I could hear it too.
Hear the audio. Yep.
You
Oh, I
just...
think.
Yeah, just...
Are you in Dan's live, everybody?
Oh,
Can you guys hear it? Let me play it again.
Cycle is complete via text messaging that is done by Twilio that provides a bridge between a cell phone carrier and Wi-Fi. We will build a system that will be placed on the side of a laundry machine that has Bluetooth and Wi-Fi and sound and vibration sensors that will communicate with either a computer or a smartphone.
For our use case diagram update, compared to our last semester in our preliminary design, we decided to opt out on not implementing the open or close notifier, as it is not our focus on this project. We would rather have it focus on one function and do it well properly than to have many other functions that don't work too well. As far as the user setup, we will develop a web app where the user will register their name and their phone number to receive the text updates. In terms of the notification system, the laundry reminder system will notify the user with a text message within 10 seconds of the washer or dryer has finished its cycle. You can see here that the system is run by the Raspberry Pi 3. You can see the actor and the washer dryer machine interacting with each other. Next slide.
This is our system block diagram / subsystem update. For our subsystem update, we were able to flash Raspberry Pi OS onto a Raspberry Pi 3 and code basic Python code for testing the vibration sensor. We have decided not to add a motion sensor and focus more on Laundralarm's cycle detection function and user connectivity. For the hardware enclosure, we want to get the code up and running and have it fully functional before we do any designs for the case. Once we perfect our code, we will begin our prototype. We were able to test the vibration sensor on the washing machine, but it barely detected any movement, and Adonica is in the process of going into the potentiometer setting and adjust the sensitivity on the sensor chip. Once the sensitivity of the chip has been calibrated, we will have a better idea of where each component can be situated within the casing and on the machine to get better results.
So for our prototype update, this is kind of like what we have right now, and it's not our finalized version. As you can see on the picture on the left, we have used a Raspberry Pi 3 with 3 female jumper wires connected to the vibration sensor. The input of the sensor is connected to the GPIO pin number 17 on the Raspberry Pi, along with the power and ground connections. On the right side here, this is basically a video demonstration on how the system will work. And then we'll play this video right after this slide. But to sum up this video, you can see that once movement is detected, the output will display the action saying, any string of text saying, oh, movement is detected. We will still need to add more code to this project as we learn Python and test thoroughly before creating cases. Next slide.
Over the summer break, we continued to individually research and learn a programming language to integrate into the device. Due to COVID-19, we did not meet up physically, and although we did plan to meet bi-weekly virtually, we did not due to summer vacation. But once school started, we did meet together and swap hardware. As of the 4th week of September, we have begun testing our hardware and continue to do further research as October approaches. We will integrate the potentiometer sensitivity settings on the vibration sensor and continue to work on code. Compared to our proposed schedule from last semester, we are right on track with the development of our device. In November, we will design and test and debug our prototype, and then in December, we will finalize our project for submittal.
So we've had some updates to the budget since we really started working on the hardware. Most of the newly purchased items were bought so that all of the test equipment could be kept separate from personal equipment, such as keyboard, mouse, monitor, and things like that. While this equipment was purchased for the project, it can definitely be used for future projects or for personal use. Overall, we've seen an increase of about $52 from our original budget. At this time, we do not have work hours factored in to the overall budget due to our kind of pace of scheduling. Next slide.
So as you saw in the demonstration video, we used the Raspberry Pi Zero. We initially thought the Raspberry Pi Zero will be perfect for the project due to how tiny and portable it was. But due to its flat GPIO header, it was very difficult to keep the vibration sensor connected all the time without soldering or using a breadboard. So when we tested out the vibration sensor, it wasn't that stable as it would lose connection all the time. So in order to resolve this issue, we switched to the Raspberry Pi 3. And one of the best features it has is its 40-pin extended GPIO, which made it easy to use the 3 female-to-female jumper wires to ensure a stable connection between the vibration sensor. Lesson learned was that we should have at least got hands-on on the Raspberry Pi over the summer to at least study and learn what it's capable of doing, and also get used to Raspberry Pi's environment, which is Linux. One big challenge is learning code. I haven't actually taken actual Python course in school, but I'm still trying and using online resources to learn and try to perfect the code based on our functional requirements. Next slide.
So the success of our design will be predicated on the accuracy of the vibration sensor, which we're currently working to calibrate using the potentiometer on the SW420 sensor chip. The device's portability, or its ability to be used on a wide range of laundry machine models and in various positions on those machines, is also one of the major points of our success criteria. The accuracy of the notification system and the overall ease of use for the potential consumer are the final two points of our success criteria. The resulting device should be something that's easy to set up by the end user and is simple to use. Next slide. Well, kind of in conclusion and a summary of our thoughts, as it was stated before, we did have plans to follow a more concrete schedule over the summer. And while it was mainly individual research, we found that our work schedules and just life in general kind of kept us from making project meetups, of course. It wasn't really known if it was safe because of COVID. And it also kind of kept us from making steady updates a priority. Instead, we took our time to learn the material at our own pace. Once the fall semester started, we were still pretty much on track. We were able to get the hardware together pretty quickly. So at this time, we are still right on schedule, despite our class and work schedules. So we're kind of like working and accruing knowledge like every day even, and building off of each other's knowledge. But even then, our project will be completed on schedule. Next slide. So that was our presentation. Does anyone have any questions for our team?
Okay, thank you. That came across pretty well. Does anybody in the audience have any questions? Okay. So I'm a little concerned about the sensor. It looks from what you were saying that it's not as sensitive as you thought it would be. What happens if playing with the potentiometer to try and adjust the sensitivity doesn't work? What do you do then?
I guess we could try and find a new sensor. Can you hear me? Am I right? Hello?
Yeah, I can hear you.
Oh, okay. I don't think, I think it'll be okay. I've actually adjusted the potentiometer so that it's more sensitive. And with whatever case we design, we can make it so the potentiometer has a bit more room to move and experience the vibration while everything else is stationary for the device. So I haven't tested it out on the machine yet, but it is very sensitive when you turn it down.
Okay.
And I think it should work. So now I'm working on timers in conjunction with the potentiometer, just encoding, so we can move on to cycle detection.
Right. Right. Okay, that sounds good. I don't think I have any more questions. Oh, I did have a suggestion, all right? And I don't know, again, whether it's going to be possible. I would actually like to see if you could get it to run on the Raspberry Pi Zero. Certainly get it all working and everything on the 3. But I would really like to see just the form factor of the Zero is quite small, quite a bit smaller than the 3. So I would like at least as a stretch goal, shall we say, for the team to try and do that. Okay, thank you.
Yeah.
Any other questions for the team for Laundralarm? Okay. Thank you everyone for coming along and presenting. I appreciate it. I'm going to if you could please upload your presentations into the into Blackboard, into the appropriate presentation piece, that would be good. That way I can actually use the rubric to grade it. A reminder for everybody, and I think I've been telling this to everybody anyway, but just repetition is good. Once you get something working, take a video of it, right? That way you can see that it's working. I've looked at a couple of the capstone cohorts. The one that I took, I personally have only taken one other cohort through their capstone project, but I've sort of looked in on some that Professor Broderick has run, and the problem is that usually in the last 2 weeks of semester, you're racing to get everything working, and it suddenly works, and then you say, oh, I've got to do this one last thing, and then it blows up, and you don't have a picture of the thing, whatever it is, working as well as it was working, and that's a bit disconcerting, right? And but at least if you have the video, and that's, I mean, I think that's why the groups have shown some of the videos here now. But take a video and keep it somewhere safe so that you can demonstrate that later on. Okay, thank you very much, everyone. I'm done. Does anybody have any questions for me? I'll take that as a no. I don't see anybody furiously running to unmute. So let's leave it there, and I'll talk to everybody at the usual time next week.
Thank you, Professor.
Yeah.
Yep.
Thank
Have a
you.
good.
Yeah.
We'll see you on Saturday. So.
Yep. Sounds good.
Okay.
Bye bye.
Good day.